Let f of x equal x squared minus 36 over 2x plus 9. And we want to find the domain, the y-intercept, the x-intercepts, vertical asymptotes, and horizontal asymptotes. So let's get started. So first off, the domain. The domain is going to be anywhere except for a 0 of the denominator. So essentially what I need to do is find the 0 of the denominator. So if I have 2x plus 9 in the denominator and find its 0, that means I have, I set that equal to 0 and solve. So 2x equals negative 9, or x equals negative 9 halves. So negative 9 halves gives me division by 0. So I need to make sure we don't equal that value. So to write this in interval notation, what I need to do is say this is the interval from negative infinity to negative 9 halves, and then from negative 9 halves to positive infinity. And that just is all the values from negative infinity to positive infinity, except for negative 9 halves. Now, the y-intercept. Y-intercept occurs at the ratio of constant terms. But you do have to be in the unfactored form. So the x squared minus 36 over 2x plus 9 is perfect. So I'm just going to take these constants. The y-intercept has an x value of 0, and then we take negative 36 divided by 9, which is negative 4. X-intercepts. X-intercepts, these will occur whenever the numerator is equal to 0. So in factored form, that's the easiest way to identify them. So if I take x plus 6 and set that equal to 0, I get x equals negative 6. And similarly, if I set x plus 6 to 0, that gives me x equals 6. But x-intercepts occur at a point on the graph, so we would say negative 6, 0, and 6, 0. Vertical asymptotes, these occur whenever the denominator is equal to 0. And the denominator is equal to 0 at this negative 9 halves. So I have a vertical asymptote at x equals negative 9 halves. It's the value that I'm trying to avoid from my domain. And horizontal asymptotes. So the horizontal asymptotes, it depends on how the degrees of the numerator and denominator compare. So in this particular case, the degree of the numerator is higher than the degree of the denominator. So what that means is there is no horizontal asymptote. That particular value, that simply does not exist in this equation. There would be a slant asymptote, but that's not asked for in this particular problem.